कमलपटी विमलपुटी पुस्तकरुद्राक्ष शस्तहस्तपुटी कामाक्षी पक्ष्मलाक्षी कलित विपंची विभासी वैरिंची नमस्सभायै सभापतिभ्यश्च। अद्य षष्ठे दिने तृतीय सत्रे वयं स्मः। अद्य प्रोफेसर आर यशोदादेवी महोदयाः डिपार्ट्मेंट ऑफ एजुकेशन द्रविड यूनिवर्सिटी इन कुप्पम ह्यः अपि महोदयया अनुसंधान विधीनां परिचयः कृतः अस्ति। अद्यापि अस्मान् अनुगृहीतुं महोदयं मंचस्य उपरि आगन्तुं स्वागतं करोमि। अद्य विषयः अस्ति डिस्क्रिप्टिव स्टैटिस्टिक्स विषय। महोदयः अस्मान् उद्दिश्य किञ्चित् पाठयन्ति। धन्यवादः।
Most respected learned professor, Professor Nirmala Jyoti garu, Madam garu, Dean of Director of the In-Service Teacher Education Program, Professor Venkatrao garu, Coordinator of this program, Professor Chandrasekhar Rao garu, faculty members from Department of Education, visit scholars and dear students, very good morning to one and all. And in this session, we will be discussing the measures of central tendency. What exactly is meant by measures of central tendency? What are the measures of central tendency? How to compute these measures? And what are the merits and limitations of these measures, and finally, when to use and when not to use these measures of central tendency. To begin with, whenever we conduct an achievement test to the students in a classroom, frequently we observe that very few students lie at both the extremes of the distribution, and most of the students lie somewhere between the highest and lowest scores of the distribution, isn't it? This is the general tendency, right? Majority will be lying between the highest and lowest scores. Very few will be scoring at the two extremes of the distribution. So this tendency is what is called central tendency. There are three general major measures of central tendency. We all know: mean, median, and mode. Any one of these measures represents the scores in the selected group. So therefore, each one of these measures, a single score of this measure is enough to say the nature of the distribution in that particular group, because this represents the whole group, right? So, after discussing on the computation of mean, median, mode, then we go for the merits and limitations and when to use and when not to use. As we have discussed in the morning session, like ungrouped data and grouped data, here also we have these two cases where we compute measures of central tendency. Is it visible to you? Can you see this board? Yes. when the data is in the form of raw scores, right? Ungrouped data. I think you might be knowing very basic concept, so you will be knowing this. Let us, what is mean? What is mean? It is the average of all the values of the scores given in a series in the distribution. Right? Say for example, we take series of scores. 7, 4, 9, 8, 5, and 2. How to find out the average? It is sum of the values of all the scores in the series divided by number of scores. Then how do we compute this? Arithmetic mean is sum of the values of these scores divided by what about the number of scores here? N is 6. N is 6. So what is the value? It is 5.8. Is it correct? Right? Okay. How do we, what is median? What is median? Usually we say median is the middlemost score of the distribution. No. Some statisticians won't accept. Median is the value of the middlemost score in the series of the distribution when they are arranged in either ascending or descending order. Right? For ungrouped data, how do we compute median? What is the formula for computing median? Let us arrange these scores in some order. 2, 4, 5, 7, 8 and 9. The number of scores here is 6. Even number. Okay. Suppose this is not there. Now there are odd number of scores. Right? Okay. When the number of scores is odd, number of items is odd, what is the formula for computing the median? The definition of median says middlemost value of the score given in the distribution. So, which is the right? So, what is the formula for this? Third score, right? When there are 5 number of scores, third score means n by 2. If we say n by 2, you will get, because this is odd number now, you won't, it will be in decimals. So, n plus 1 by 2th score, that is 5. But if it is an even number, what is the formula for computing median? Usually, we can say that the average of these two gives you the median score, right? Then, n by 2, right, plus n plus 1 by 2 plus n by 2 plus 1, average of these two scores gives you the median value, right? Simply we can say the average of middlemost two scores is the median score. If we put it in the form of an equation or formula, this is the formula to compute median when the number of scores is even, right? What is the meaning of mode? How do you define mode? How do you define mode?
Which is the repeated number.
The value of the frequently occurred scores in the distribution, right? So in this, could you find out any mode here? So let me add one more score. Now which is the mode here? 2, right? So this is how we compute the measures of central tendency for ungrouped data. Very simple process. But when we come to the grouped data, we need to apply some more rules for computing. We know what is group of data. When do you call the data is group? When do you call that data is grouped one? Whenever the data is classified in the form of classes, groups, frequency distribution, if it is in the form of frequency distribution, then we say that it is
Group of data.
Let us compute arithmetic mean for the group of data. In the morning we have taken frequency distribution, no 20 to 24 like. Okay. Take the data, class intervals, 20 to 24. I prefer only exclusive, right? Method 30, 30 to 35, 35 to 40, 40 to 45, 50, is it up to 70? Is it up to 70? Morning I have given you this distribution.
Yes.
Please tell me the frequencies. 1, 2, 4, 8, 11, 9, 7, 4, 3, 1. And we all know the formula for arithmetic mean using long method. Why do you call it as long method? We directly compute mean from the mid values of these class intervals. Right? So, what is the formula for computing mean in this case? Arithmetic mean is summation X by N. What is the formula for ungrouped data? Sigma X by N. Right? Because this is grouped data, we add fx, right? So, as per the formula, we know n. What is n? Sum of the scores. It is 50. Okay, we know n, and we also know frequency. So, what else is required?
X.
What is x? Mid values of the class intervals, right? So we have to compute the mid values. How do you find out the mid values of the class intervals?
20, 25 by 2.
Usually statisticians give a formula for computing mid values. Simply we can find out this is 22.5, 27.5, average will take. But statisticians give a formula for this. What is that? Lower limit, lower limit, lower limit, plus
upper limit divided by 2.
Okay, lower limit plus upper limit by 2. They give the formula in another way. What they say? Lower limit plus difference between the 2 minutes. Average of the difference between 2 limits. What is the difference between 2 limits? 5. If you take the average, it is 2.5. So it is 22.5. But simply we can say it is the average of the lower and upper limits. 32.5, 37.5, 42.5, 'Right? What the formula says? Arithmetic mean is summation fx by n, sigma fx by n. So what is that we need to find out now? We have to find out the product of fx. We have to multiply these two. If you add all these values, you will get sigma fx. This is capital, this is n, right? So divide sigma fx by n. You will get arithmetic mean. But this is very laborious process. Why? You have to multiply all the mid values with the frequencies. The mid values are they are in decimal form, right? With big scores. Definitely it is time consuming. So therefore, statisticians has No, they have given us a shortcut method. We call it as very short method. Why it is called short method? Why it is called short method? Instead of multiplying big values, scores, they have simplified the values so that almost the computation part has been simplified. Okay. So what is the formula for computing arithmetic mean using short method? Can you tell me?
AM plus or minus
A plus sigma FD by N
Into CI.
into CI.
Okay. See, there are different notations. In different textbooks you will find different notations. So sometimes we will write it as X dash bar. Okay. What is this A? Assumed mean.
Assumed is
What is this assumed mean? Uha. What is the criteria for that uha? How do you assume? What is the criteria for assuming that this will be my assumed mean? What is the criteria? Can I take this is my assumed mean?
Madam, frequency. In the frequency, which is the largest, biggest value, that will take.
Of course, right? Okay. The mid value of the class interval. One option is
11.
in the middlemost
Yes.
position of the distribution, and the other option is where the number of frequencies are
Include.
more. Okay. So in this case, I will consider 42.5
Yes.
as the assumed mean, because the frequency when compared to the other class intervals is more here. More number of students have scored between 40 and 45, and almost it is in the middlemost of the distribution, right?
Yes.
Okay, we know arithmetic mean, assumed mean as 42.5
5.
plus. We know n and we know what is the class width. What is
5.
class width here in this case?
5.
5. How do you compute it?
Class difference between.
Madam has focused on how to find out the class width. The difference between the consecutive either lower limits or upper limits. Okay, in this case it is. In this case it is 5. We know. Then what is this D? We also know frequency. What is this D?
Deviation.
This is called deviation. How do you find out this deviation? How do you find out this deviation? Yes? How do you find this deviation? Scores deviated from the assumed mean divided by. If you apply this formula, you will get deviation, right? Later at the end of the problem solution, I will tell you why should we divide the deviation. Deviation means it is enough if we take away assumed mean from. If I take away assumed mean from the mid values, why should I? That tells you this is deviation. Why should I divide it by I? I'll tell you at the end. Okay. So let us apply this formula to find out the value of D. We consider this. Here this is our assumed means. All these are the scores, X values. Right? A minus A. This is the formula here. X minus A it is? Right? this is x, minus a 42.5. You'll get how much you'll get? Minus 5. Because we are dividing it by 5, you will get okay. This is D, right? Right? So, because if I don't use this I here in the denominator, you'll be getting minus 5, minus 10, minus 15 and minus 20. Again, this will be a laborious process because in the next column you have to find out the product of f and d. So to avoid this laborious process, in the formula itself, we have taken it as the deviation divided by I, class width. Now it becomes very, very simple. It is minus 1. You need not even take it, okay? Directly you can write minus 3, minus 4, and because the values are bigger values, you can write 2, 3, 4 and 5. Now you have to find out f into d. Compute the frequencies and find out the product of frequency and the deviation. Minus 4, minus 6, minus 8, minus 8, 0, 9, 14, 12, 5. See how simple it is than the previous procedure, right? Very simple. But no time we can compute this, right? So find out the value of this.
Minus 26 above.
Minus, oh, this value is minus 26.
Yes.
And this is? Yes?
52.
52. So take away 52. 26 from 52, you'll get? 26. Right? So substitute that value in the formula. Sigma FD is 26 divided by n is 50 multiplied by
5.
Okay. Why we are multiplying again here with I in the formula? Why we are using here? Tell me. Because mathematically it is not required here, but for simplification purpose we have divided it by I. So to nullify that effect, again we are adding the I. We are dividing it here. To balance it, we are multiplying it by I. Clear? Okay. So what is the value? What is I? It is 5. Don't get confused. We can use, it should be commonly used. So this is how, any doubt? We'll compute arithmetic mean using the short method. Right? Then how to compute? Is it clear? Any doubts? Then how to compute median for the grouped data? What is the formula for median in the grouped data? For the grouped data, median is equal to L plus
N by 2
N by 2
minus
minus M by F into I or C. Right? What is this L? Exact lower limit of the
Madhyam.
lower limit of what? What is that we are trying to find out now?
Madhyam.
We are trying to find out the median. Right? What is median? The middlemost value
Yes.
of the score in the distribution. Right? Where the middlemost value will be there? ఎక్కడ ఉంటుంది middlemost value?
అదే మాట.
చెప్పండి.
పెద్దది.
n ఎంత? 50. సో మిడిల్ మోస్ట్ అంటే ఎక్కడ ఉంటుంది? 20.
20.
25th కదా ఆ 25th ది మీరు ఇక్కడ చూసినట్లయితే if you take the cumulative frequency తీసుకోవాలా దీనికి మనము తీసుకోవాలా 25th స్కోర్ ఎక్కడ ఉందని తెలియాలి కదా English sorry okay is it necessary to find out the cumulative frequency
Yes.
why because n is 50 median is the middlemost score so it will be at 25th score right it is the 25th score we have to find out where the 25th score in which class interval it is right
Yes.
so to know that we have to find out cumulative frequency 1 3 7 15 26 35 42 etc right 46 49 and 50 so up to here only 15 candidates are there up to here means up to 40 suppose this is marks obtained by the students so up to here only 15 students are there 25th student is in this class right so this is called the median class 25th student is in this class so therefore this is called median class so the exact lower limit of this median class is what is the L right what is the exact lower limit of this median class
40.5.
exact lower limit what is the lower limit 39.5 right 39.5 plus n by 2 25 what is this m cumulative frequency above the median class cumulative frequency above the median class so it is 15 frequency of the median class is 11 into 5 so this is
small correction because it is continuous series. So the lower limit is 40 only.
40.
40 only.
Because of inclusive series.
See, the limits should be calculated like this with the arrow mark. 40 plus 40.
average of these
Average.
two.
So, yeah.
Average of the previous and the next class intervals lowest and higher lower and upper limits gives you the exact lower limit of the median class okay
Here it is
So 40 plus 40, 85 plus
40.
39.5.
okay so this is 40 25 minus 15 by 11 into 5 so this is L this is frequency this is cumulative frequency right
Okay.
so by simplification you will get the median value is it clear now what is mode
Frequently
third
repeat the
value of the scores in the distribution what is the formula for mode whenever we are given the values of mean and median we can compute from those values what is the formula for mode in that case mode is 3 median minus 2 mean anyway we know the values of mean and median by substituting these values we will get mode suppose these values are not known we have to anyway compute the value of mode what is the formula for mode in that case
Next na, how it's the
F.
L plus
F1
F1
minus
F1 plus 2 into I. Again you can denote it as maybe F1 dash, right? Okay.
Madam F0 minus F2
Group data.
Oh.
CAS teacher group data जानते कर
अरे बेसिक knowledge जानकगल तत्र throughput data
For throughput data, right? So, what is F1? What is F2 here? F1, F2? Wait, let me. It will be easy for me to pronounce this. Let me use this F1, F2. What are the F1 and F2? You know what is L? L is exact volume unit of the model class, as in the case of median class. What about F1 and F2?
Frequency. Yeah.
Frequencies of
Upper one.
the adjacent model class.
Yes, ma'am.
We have two frequencies adjacent to model class, right? This is one frequency, this is one frequency. When this is the model class, is this the model class in this case? Of course, this is median class.
Median.
This is model class also. Why? The frequency. This is the highest frequency class, right? So therefore, this is F1. This is F2, right? This is F. Clear?
Yes.
So substitute the values in the formula. L is 40 plus 9 by 8 plus 9 into 5. By simplifying this, you'll be able to find out the value of the mode. Right? So this is how we compute the measures of central tendency for grouped and ungrouped data. Now the point is when to use mean, when to use median, and when to use mode. Suppose the researcher is very particular about most reliable and accurate data. I think I can go for mode. Can I consider mode? Suppose the researcher is very much particular about most reliable and accurate measure of central tendency. Should I go for mean or median or mode? What if I consider mode? Is
There
it
is
not
no-
most reliable and accurate?
Yes, ma'am.
Why?
Sometimes only we can use mode.
Because I am taking into consideration for computing this measure of central tendency only basing on the highest frequency.
Frequency.
Is it correct?
No.
No.
It is not reliable to all.
Right? Very good. Then can I consider median as the reliable, accurate measure of central tendency? Yes? Median. Is it the accurate measure of central tendency? Yes or
Also
no?
average only.
Anybody from this side? Can median be considered as the most reliable and accurate measure of central tendency? Yes or no? Please tell me at least whether it is yes or no. No. Why? Because basing on the middlemost score of the distribution, I am computing median, right? So I am not taking into consideration all the scores in the distribution. Therefore, median is also not a best measure of central tendency. Then which is the best measure of reliable measure of accurate measure of central tendency? Arithmetic mean. Why? Because it takes into consideration all the scores in the distribution.
Average.
It takes into consideration all the scores. Therefore, we can rely on the measure of this central tendency, right? Okay. Next. So when can I choose this mean? Number one, when I am interested in using most reliable and accurate measure of central tendency. Number 2, when I am also interested in finding out the further statistics, I want to go for standard deviation, I want to compute correlation method, coefficient. If I compute mode as the measure of central tendency, can I apply this for my computation of standard deviation?
No, madam.
Correlation, Pearson product moment correlation? No. So when I am interested in finding further statistical techniques, values, then also I should depend on
Mean.
I should use arithmetic mean. Okay. Similarly, when all the scores in the distribution are available, also I can go for measure of arithmetic mean as the measure of central tendency. Right? Coming to median. When can I use median? When can I use median?
When we want to know middle of the scores.
When I am interested in finding out the middlemost value of the distribution, and when all the scores in the distribution are not available, it will not get affected. Even if I compute median, it will not get affected, because in median we will be considering only the middlemost 50% of the scores. Right? Extremes I am not considering. So therefore, even some scores are not available at the extremes in the distribution, it will not affect our results. Okay. So similarly, when can we go for mode? Whenever I am in a hurry to get quick measure of central tendency, even if it is not an exact one, even if I am satisfied with an approximate measure of central tendency, but the thing is I should get a very quick result, then I can go for mode. Right? So what are the other cases where we can use mode? Other cases where we can use mode? In most of the business, in market situations, see, what about the sales? What is the demand? For which product the demand is more? What about the sales in particular? Which goods? మామూలుగా అంటుంటారు కదా, ఇలా ఏమో ఒక వర్డ్ యూస్ చేస్తారు మామూలుగా, భయంకరమైన డిమాండ్ ఉంది దీనికి అని. ఎలా తెలుస్తుంది? హౌ కెన్ వి కమ్ టు నో?
రివ్యూ ఇస్తారు మాట.
So in such situation, most of the people in the field of business, they just depend on mode as the measure of central tendency. Okay, so this is how we can select when to use mean, when to use median, when to use mode. Similarly, what are the merits and demerits of these measures of central tendency, advantages and limitations? Coming to arithmetic mean, can you tell the best characteristics of arithmetic mean? What are the merits of arithmetic mean as the measure of central tendency? The first thing is, it takes into consideration all the scores. Number one, is it a merit or a limitation? If we say that this is a merit of mean, then this will be the limitation of the other two measures. Right? And second one, this will be useful for us in computing the other statistics like standard deviation,
Yes.
etc. Right? And if it is a merit of this, it will be the limitation for the other two, median and mode, measures of central tendency. Right? What else is the merit of arithmetic mean? Any other merits of this measure of central tendency? Similarly, what are the merits of median and mode? Suppose if I ask you the merits of mode,
very easy method.
Very
to
easy
find,
method. Quickly you can find
yes,
out the
yes.
measure, right? For immediate application, in no time if you want to apply it. Okay. And what about the merits of median? Merits of median. Even if the complete distribution is not available, you can find out the measure of central tendency. It is very useful. When the graphical representation is available, you can find out median from graphical representation. If a frequency polygon is there, if the cumulative frequency curve is there, if percentage cumulative frequency curve is there, we have computed in the morning, right? We have discussed in the morning how to draw the frequency polygon, frequency, cumulative frequency curve, cumulative percentage frequency curve. When these curves are available, we can compute mode and median from those graphs, right? So these are all the merits of mode and median. The limitations we know. What are all the limitations of mean can be considered as the delimitations. Merits of mean can be considered as the limitations of median and mode, right? So when the extreme scores are there in the distribution, mode will not get affected. Right? So that is a merit of mode, whereas this is the demerit of arithmetic mean. Because arithmetic mean is a very sensitive measure of central tendency. Even single score can affect the measure of central tendency. Okay. When we have a distribution with open end, the data is not complete, then also we can go for mode. Even we can go for median, not the arithmetic mean. So again, when there are no extreme scores in the distribution, we use arithmetic mean. So this is about the concept of central tendency, measures of different measures of central tendency, computing the measures of central tendency, and when to use and when not to use these measures of central tendency, and some of the merits and demerits of these measures of central tendency. And now I request Professor Nirmal Jyoti Madam Garu to add if I failed in.
Not failing. Oh, don't use such words.
కాదు మేడం, ఎక్కడైనా నేను ఒకవేళ మిస్ చేస్తుంటే ఏదైనా పాయింట్స్ నేను ఏమైనా మిస్ చేస్తుంటే మేడంని మనందరినీ కూడా ఎడ్యుకేట్ చేయవలసిందిగా రిక్వెస్ట్ చేస్తున్నాను. ప్లీజ్ మేడం.
For giving me this opportunity, Madam has nicely described what are the measures of central tendencies and how to calculate and when to use them. And I will give you in nutshell why any one of the measure of central tendency, for that matter even the measures of variability, can be considered as a good measure or a measure with limitations. You yourself can know if you know the characteristics of a good measure of central tendency, for that matter, or for a measure of variability. Measure of variability or a measure of central tendency, there should be certain criteria. I will tell you the characteristics of a good measure of central tendency. The same things holds true for measures of variability also, or measures of dispersion also. And let us see If you keep all these things in mind, you yourself can estimate when to use any measure of central tendency for that matter, or even for a measure of dispersion. And now let us see the characteristics of a good measure of central tendency or variability. It holds true even for variability. One, the first thing is it should have a rigidly well-defined formula. Rigidly well-defined formula. Okay? It should have a rigidly well-defined formula. Does mean has a rigidly well-defined formula? Yes. Median has a formula?
Yes. Yes.
Mode has a formula?
Yes.
See, do you think mean has a formula? Okay. Median, it has a formula, but not rigidly defined. Why? Hello, sir. Median has a formula. It has a well-defined formula, but not rigidly defined. How? Why? Because when an odd number is there, we use one formula. When an even number is there, we use another formula. So it is not rigidly defined. And mode has a formula. And mode without formula also we can calculate. Just by looking into the distribution or just by looking into the graph, we can calculate. The formula, whether required or not at all necessary. And third thing, when you use a formula, it should take into account each and every observation of the group into consideration. You are not supposed to leave. A candidate has got 0. Let me discard this number. That cannot be taken into account. Each and every item of the group should be involved in its calculation. The formula should incorporate. The formula should involve. Its calculations should be based upon each and every observation, should involve each and every its calculation. The formula should involve each and every observation of the group. Okay. It should take into account all the items of the series into account. It should take into account all the items of the group. And do you think mean is taking all the items of the group? Mean, does it take? Yes or no?
Yes.
Yes, it takes into account. Coming to median? No. What is median? Median is that value which divides the group into two equal halves. Above and below, there should be equal number of cases. And suppose you arrange the group like this, this should be, there should be 50%, and this side, above and below this score. Suppose this score is say X. Scoring above X, there should be 50% of cases, and scoring below 50%, there should be 50% of cases, and that value is called as median. Therefore, in calculation, we take only middle point. Therefore, it does not take into account all the observations of the group. Then, it should not be affected by extreme scores of the group. Extreme scores of the group. What are the extreme scores? Suppose this is class interval and this is frequency. Say this is somewhat normally distributed. If you draw a graph on the frequencies and the class intervals, you get more or less like this, the graph like this. Okay? But imagine that here in between 10 and 19 there are 12 students, and suppose for this you say when the mean comes as x, say for example x comes as 48 for example, what does it mean? X bar is nothing but mean. What does it mean? It means that on an average every student is getting 48 marks. And here, what you are doing, here, though the students are in between 10 and 19, you are telling them on an average, even they are given higher marks. Whereas here, they are given lesser marks. And your mean is affected by the extreme scores. Suppose the series is like that. If you calculate mean value for such a series and you are not giving the representative value, the exact average of the group, because here more number of students are overrated. So that will, in such cases, you cannot calculate. So it should not be affected by extreme scores. So our median is not affected. Our mean mode is also not affected. Why? Because it is the most commonly occurring value is referred as mode. The most commonly or the most frequently occurring value. And the median is nothing but that value that divides the group into two equal halves. So we are concentrating on the middle value only. And another thing is, it should not be affected by sampling fluctuations. In other words, it should be least affected by, the same thing can be put it as, it should be least affected by it should have sampling stability. What is meant by sampling fluctuation and what is meant by sampling stability? You take for example, this is the population of this group of the training program workshop. This is the population. I want a sample of, say, size 10. How many I want? only 10 people, 10 persons from this group I should select. I can select randomly, say one sample, sample 1. I can calculate mean or median or mode, no, for this sample 1 consisting of 10 members. Suppose I ask her to select a sample, do you think that she will select the same sample that I have selected?
No.
No, her sample will be different. Like that, there are n number of samples that can be selected from the same population with the required size of sample. With the required size of sample, out of the population, number of samples can be selected. For those number of samples, if I calculate any measure of central tendency, all the samples should represent more or less the same number. Suppose I calculate arithmetic mean for sample 1, sample 2, sample 3, like that, say n samples, the arithmetic mean that I calculate should be more or less equal. It will be equal if I follow correct sampling procedure. If I follow correct sampling procedure, the arithmetic mean that I calculate for my sample will be more or less equal if for your sample also, if you follow the same scientific procedure of selecting the sample. So for arithmetic mean, this will be true. But whereas for median and mode, it will not be the case. Why? Because for my sample, the median may be something different, and for your sample, the median may be something different, though arithmetic mean will be one and the same. So, if it differs from sample to sample, it is called as sampling fluctuation. If it is more or less equal, it is called as sampling stability. So, which has sampling stability? Which has sampling stability? Mean. Why median and mode do not have sampling stability? Why?
If sampling same, mode may be different.
Why it is not? Why it is affected by fluctuations? The major thing is all items should, when it is involved in calculation, it will be least affected by sampling fluctuations. When it does not involve, then it is affected by sampling fluctuation. It doesn't have sampling stability. And another thing is, it should be amenable for further algebraic treatments. That means it should be used in further calculations. So, why median and mode are not used in further algebraic treatments? Because they are not stable. They do not take each and every item of the group into calculations. In their calculations, they show. Therefore, we don't use median or mode in further algebraic treatments, or we don't use. And if you consider, if you keep these 5 points in mind, you yourself can estimate whether it has soundness or weakness. And the merits and the demerits, you yourself can. And another thing, sir, open-ended, closed-ended means class interval will be from here to here, and frequencies are also there. And if everything is there, then we call it as a closed frequency distribution. Suppose if I say in between 10 and below 20, there are 10 students. How do you calculate arithmetic mean? How do you calculate arithmetic mean? And in between 20, 30, there are 30, 40, there are, and all the things are there. Here all frequencies are there. How do you calculate for this type of series? Can you calculate? Fx, can you calculate? What is x? X is the mid value, midpoint of Ci. And Fx. Do you calculate for this? What is the x for this? Below 20. Is there the lower limit? It can be 0 or it can be 90. So you can't calculate. Similarly, above 70, there are so many students. They may be scoring 70 or 100 or 71 only. You don't know. Therefore, for open-ended, they are called as open-ended distributions. For open-ended distributions, you can't calculate. And another thing is, the group is like this. The items of the group are like this. One person got 10, 12, 35, 40, 80, 90, 100. When you calculate mean, how much it comes? It is more than 40. But these three candidates are overrated and they are underrated. Okay? This is called as a heterogeneous type of group. When the group is more or less homogeneous, you can calculate arithmetic mean. When the group is heterogeneous, you can't use arithmetic mean as a representative value. Okay? And these are some of the points you should keep in mind while knowing about measure of central tendency or measure of variability. These are the characteristics. 5 characteristics, if you keep in mind, that is sufficient. Okay? Thank you very much. Thank you.
एतावत् कालपर्यन्तम् अस्माकं कृते स्वज्ञानरूपी यशं दत्तवद्भ्यः यशोदामहोदयेभ्यः विश्वविद्यालयपक्षतः कार्यशालापक्षतः धन्यवादं वितनोमि। अनन्तरं तद्वदेव निर्गतं मलं यस्याः इति निर्मला महोदयाः भवन्ति तासामपि विभागपक्षतः अनन्तरं कार्यशालापक्षतः धन्यवादं वितनोमि। तदनन्तरं सर्वेषां छात्राणामपि धन्यवादं वितनोमि।
On the dais. करतालनेन स्वागतम्। यशोदा मडम महोदयानां सम्मानम् अस्माकं कार्यशालायाः निदेशक महोदयः एवमेव निर्मल ज्योति महोदयाः अस्माकं यशोदा महोदयानां सम्मानं करिष्यन्ति।
Okay. Next girl.
Yeah, smile.
अस्माकम् आह्वानम् अङ्गीकृत्य दिनद्वयं प्रोफेसर् यशोदा महोदयाः अस्माकं कृते स्टैटिस्टिक् विषये सम्यक् व्याख्यानं कृतवती। एतेभ्यः अस्माकं विश्वविद्यालयपक्षतः एवमेव अस्माकं शिक्षाविभागपक्षतः कार्यशालायाः पक्षतः सर्वेषां पक्षतः हार्दान् धन्यवादान् प्रकटीकरोमि। धन्यवादः।